Today we're not starting with a definition of intelligence. We're starting with a puzzle. A calculator can do something you can't. Perfect math, instantly, with zero mistakes. So why don't we call it intelligent? By the end of this video, you'll have an answer you can actually defend, and a new question that opens the rest of this channel. This one definition matters for every video after this one. Get it now, and ideas like can a machine learn and how a modern chatbot actually works will click into place faster. Skip it, and those ideas just float in space, disconnected from each other. So forget the word intelligent for a moment. Just watch two systems do their jobs side by side. System 1, a calculator. 47 plus 35. Rule in, rule applied, answer out, 82. Every single time, an identical process. Run it again, with a different problem. Same story. Instant, deterministic, exact. Nothing about how it computes ever changes, no matter what you feed it or how many times you ask. System 2 is different. It's trying to guess a hidden number pattern, one that goes up by 10 each time. It doesn't know the rule yet. All it gets back after each guess is feedback. Too high, too low, or correct. Before I show you what happens, pause and predict. Does this system get better after a wrong guess? Or does it behave exactly the same way every time, just like the calculator? Round 1. It guesses 15. Feedback. Too low. Notice, nothing has been explained to it. It only knows it undershot. Round 2. It adjusts upward and guesses 25. Feedback. Still too low, but closer. The system used the last result to inform this guess. Round 3. It guesses 35. Feedback. Slightly too high this time. It overshot, just a little, and pulls back. Round 4. It guesses 40. Feedback. Correct. 4 rounds. 0 to fully correct. And at no point did anyone hand it the rule. It found the pattern by using its own past mistakes. Let's name what we just saw. A calculator executes a fixed rule. Same input, same output. Always. No matter how many times you run it, and no matter what happened last time. Adaptation is different. It means changing your own future behavior because of what happened last time. The guessing system's second guess was different because of what the first guess taught it. Learning, properly, is adaptation applied systematically, across many examples, in a structured way, so the improvement generalizes instead of being a one-off lucky correction. That's the actual subject of the next episode in this series. Here's the general shape underneath what you just watched. Observe the current guess. Compare it to feedback. Update your next guess based on that comparison. Repeat. Every learning system you will ever encounter on this channel, no matter how advanced, follows this exact shape somewhere inside it. Now let's break it, on purpose. What happens if we take away the feedback entirely? Watch. The guesses keep coming. 15, 60, 8, 42, but with no feedback, there is nothing to adjust toward. The guesses stay random forever. Remove feedback, and this system is now behaviorally identical to the calculator, repeating a fixed process, just a random one instead of a mathematical one. Here's a trickier case, on purpose, because a good definition has to survive an attack. A thermostat reacts to temperature. Heat turns on, then off, then on again. Is a thermostat intelligent, by our definition? No, and here's exactly why. Its rule never changes. It reacts to input the exact same way, every single time. If temperature is below the set point, turn on the heat. Reacting to input isn't the same as adapting. For it to count, the rule itself has to change from accumulated feedback, not just the immediate output. You already live with both categories, side by side. A unit converter and a mortgage calculator give you the identical answer today, next year, and 10 years from now. Fixed rule, forever. Your phone's autocorrect and a shopping app's recommendations change, because they're adjusting based on your actual behavior over time. So, to recap this properly, using the exact shape we'll reuse for every episode. Problem: what actually makes something intelligent, not just fast or accurate? Mechanism: adapting future behavior based on feedback, not merely executing a fixed rule. Result: a calculator and a thermostat both fail this test. A system that updates its guesses from being told right or wrong passes it. Limitation: reacting to input isn't enough on its own. The rule itself must change, and one adjustment isn't the same as real learning at scale. Which leaves us with the real question. Can a machine actually learn? Not a 4-round toy guessing game, but a genuine pattern from real data, entirely on its own. That's exactly where episode 2 goes. Can a machine actually learn? Don't jump randomly between disconnected AI content. Follow this in order, and every idea will build honestly on the last one. Follow AllAboutAIVerse, and let's keep going.